Integration can be used to find areas, volumes, central points, and many useful things. It is often used to find the area underneath the graph of a function and the x-axis. The first rule to know is that integrals and derivatives are opposites. So this is a derivative, and this is an integral. A derivative can be changed into an integral, and an integral can be changed into a derivative. And something to also know is that sometimes to find out an integral, we can work it out because we know a matching derivative. So a derivative that has something to do with the integral. That makes the process easier because we know that they're the opposites of each other. Okay, so let's solve some examples for integration rules. So example 1 is, what is the integral of sine x? So simply to find this, we're just going to look at the rules and we're going to find what it is. So as you can see here, the integral of sine of x is equal to negative cosine of x plus c. So we're just going to write the integral of sine of x dx equals negative cosine x plus c. Okay, so it's as simple as that. You just refer to the rule table and you're going to find your answer. So for example 2, what is the integral of 1 over x? So if we look back here, 1 over x is equal to the natural logarithm of the absolute value of x plus c. So let's just write that down. The integral of 1 over x is equal to the natural logarithm of absolute value plus c. The vertical bars that we see here on either side of x mean absolute value. We put them because we don't want to give negative values to the natural logarithm function. Now let's talk about the power rule. So we know from the table that the power rule is integral of x powered by n is equal to x powered by n plus 1 over n plus 1 plus c. Okay, so now that we know the rule, we can move on. So the question is, what is the integral of x powered by 3? So in our case, n is equal to 3. So let's just write this down. Integral of x powered by 3 dx equals. So what we're going to do now is take this and write it down, but we're going to substitute the n by 3. So we have x powered by 3 plus 1 over 3 plus 1 plus c. So now we simplify. So we have x, 3 plus 1 is 4 over 3 plus 1 is also 4. So we write 4 here plus c. And this is going to be our answer. This is how to solve multiplication by a constant. So we know the rule for this is integral of cf of x equal c integral of f of x. So our question is, what is integral of 6x of powered by 2? So in this case, 6 is going to be our c, and x is going to be our f. So what we're gonna do, let's just write integral of 6 of x powered by 2 here. So what we're gonna do is take 6 and put it in front of the integral. So it's going to be equal to 6 integral of x powered by 2 dx. So now we're going to solve to this first, this part. And to do this part, we're going to use the power rule. So we know the power rule is x powered by n plus 1 over n plus 1. So we put x powered by 2 equals x powered by 2 plus 1 over 2 plus 1. And then, of course, we put the plus c. So it's going to be x, 2 plus 1 is 3, and then 2 plus 1 is also 3, so x powered by 3 over 3 plus c. And then we write the 6. So we're just going to write here 6, and then beside it the x powered by 3 over 3 plus c. And now we simplify. We can't do anything with the x, so we just leave that alone. We have 6 and 3. We're going to divide 6 by 3, which is 2. So we have 2x powered by 3, since the 3 leaves when we divide. And then, of course, we write the plus c. And this is going to be our answer. Now we're going to see how to solve when you have a sum rule. So we know that the sum rule is integral of f plus g equals to integral of f plus integral of g. So our question is, what is integral of cos of x plus x? So to do this, we're going to use the sum rule. Let's just write this down first. So we have integral of cosine x plus x dx. Okay. So what we're gonna have to do now is, well, what we have here, cosine, is basically f, and x is g. So we're gonna do the same thing. Here, they separated them into their own integrals. So this is what we're gonna do here too. We're going to have integral of cosine x plus integral of x. Then we write the dx here. And now, since we have this, we're simply going to look at common functions rules on the table beside us, and we're going to find out what each one is. So we have integral of cosine x is equal to sine x, and then we're at the plus c, and then integral of x is equal to x powered by 2 over 2 plus c. And then we put them together, because here, as we can see, they're together. So we write equal sine of x plus x powered by 2 over 2. And then we didn't write the plus c beside the sign, because we write that at the end of the whole thing. So at the end, we're just going to write plus c, and this is going to be our answer. We're going to see how to solve when you have to use the difference rule. So we know that the difference rule is integral f minus g equals integral of f minus integral of g. So our question is, what is integral of e powered by w minus 3? So the first step would be to apply the difference rule. So now we have E W minus 3, then D W equals. So we're just going to pretend that E is F and that 3 is G. So in that case, it's going to be E integral of E W minus 3 integral of 3. And then equal. So to solve these, let's just rewrite them here down. Integral of E W minus integral of 3 D W equals. Okay, so to solve these, we're just going to look at the table as a reference as to what to do. So for the E, we're going to leave it as is. So we're going to write E powered by W, and then minus 3 is a constant. So as we can see, the first rule here, constant is to just put an x beside it. In this case, our x is a W. So what we're going to do is write 3 powered by W. Not powered, 3W plus C. And this is actually going to be our answer. It's as simple as that. Just outline it. And yeah.